Okay, so to do 5.2, number 23, what did you start with?
I did r squared plus 3r plus 2 is 0.
R squared plus 3r plus 2 is 0?
Yeah, then I got r equals minus 1 and minus 2 after I factored.
Oops. So you factored, and then you
So I
got
got r plus 1 and r plus 2.
Cool, deal.
Parentheses and all that.
Factor, zero product rule. Apply the idea of doing algebra.
Sure.
Okay? So here you are. Then what?
And then I was confused.
Oh.
Okay, I didn't know what to do for the initial. Well, then I got my general solution. I got y equals c1 e to the minus x plus c2 e to the minus 2x.
Okay, I'm down with that.
Okay,
Right?
then
These
I
should
got-
be your
then I got
e to the
stuck.
rx's, right?
Yeah.
And they're different, so, right, if they were the same, right, if I got minus 1 and minus 1, then I'd have to like slap an x on something, but whatever, I don't have to. Okay, so I'm chilling here, and then what?
We could derive it to get to y prime, but I'm not sure exactly what to do here. This is where I got stuck.
Okay, so I think you're going to get two equations here. You're going to get one equation that's plug 1 into this, right? So if you plug 1 into this, you're going to get 1 is c1 e to the minus 1 plus c2 e to the minus 2. I mean, negative 1 equals that stuff. Okay? And then you could differentiate, right? So you get y prime should be minus c1 e to the minus x minus 2 c2 e to the minus 2x. And then you're supposed to also evaluate this at 1. Right?
There was like an initial thing at the beginning when there was a singles problem that you had to do this according to the method suggested by exercise 22.
Yeah, so another thing you could do is think, okay, so y solves this, right? So I could shift y around so that my initial conditions would be at 0. I'm going to show you this way first, and then I'll show you that way, and we'll see that they're pretty much the same thing. So if I plug in, this was x equals 1, right? What am I plugging into y prime?
Also 1.
Also x is 1. Okay, so if I plug that in, I get 4 is
Negative c1 over e.
negative c1 e to the minus 1.
Or
And then minus 2c2 e to the minus 2. Right? And then you could be like, oh, hey, let's see if I just straight up add these together. You see why it's a good idea to add these together?
We'll solve for c2.
Yeah, it's not always a good idea to add them together, but in this case, it happens to be that I have c1 e to the minus 1 and minus c1 e to the minus 1 there. Right? So that's going to be a big old fat 0 there. And then I'm not going to overburden your math skills, so I'll tell you that 4 minus 1 is 3. And then maybe you guys can tell me this one?
Negative c2 e to the minus 2.
Negative c2 e to the minus 2. Oh, okay, so that seems like something I could solve, right? So I think I get c2 is negative 3, oops, negative 3 e squared. Yeah? Okay, then where do you get c1?
Plug that back in.
Yeah, take that, plug it back into where?
I don't think it would matter, but you could. I think the y one is nicer than that y prime.
Yeah, I'm with that. It doesn't matter. Pick one. I'm going to take it and stuff it in there. Right? And so out of that, I'm going to get negative 1 is c1 e to the minus 1 plus, minus rather, minus 3e squared e to the minus 2. What's e squared times e to the minus 2? 1. Okay, so I got negative 1 is c1 e to the minus 1 minus 3. Then I could
Add 3 to
divide
both
it
sides.
into -1 minus 3 off that for your side. Or no.
Add 3.
close, add 3 first,
Yeah.
and then divide by e to the minus 1. Or multiply both sides by e. So I think if I add 3 to both sides, I'll get 2. So I'll multiply by e, so I'll get 2e as c1. Up to algebra at least. Okay, so then what do I do with those?
Plug them all back in.
Those go back into the beginning, right? And so your y is c1, oh wait, what was c1?
2e.
C1 was 2e. So I got 2e times e to the, I'm going to put an e to the 1 there just for clarity. So I got 2e to the 1, e to the minus x, plus, oops, no, minus 3e squared
E to the minus 2x.
e to the minus 2x. And then if I fiddle that about a little bit, I'll get, and I'm going to write this up top because I want to keep it around. So I got y is 2e to the x plus 1. Right? No? No. No. I'm going to mistake. What did I
That
do?
would be negative x.
Negative x.
Negative x plus 1 minus 3
-2x plus 2.
e to the negative 2x plus 2. You guys all with that?
Oh, so that's the shifted thing.
Yeah, so
Final part.
this is not what they wanted me to do, right? What they wanted me to do was shift this thing. Okay, so my claim is that that comes out in exactly the same way with just slightly different technique. Right, so I found, right, going back, I did reasonable DE stuff, right? And we got y was c1 e to the minus x plus c2 e to the minus 2x. Right? Okay, once I had that, then I may do this other trick, right? So I think to myself, well, my initial condition's at 1. That sucks. I'd rather have it be at 0, because then all the e's would go away. Right? Okay, so if I want to plug in 0, well, I really want to get my initial condition at 0, right? So what are they suggesting? How do you shift this?
Shifted
It would be r, instead of rx, it would be rx plus x naught. Or was it x minus x naught?
Yeah, so I think you want to do z is y of x minus 1.
For this one though, right? If it was something, if it was your.
Yeah, what I'm doing is I'm subtracting this variable, right? You guys see that? Cool. Okay, this is also a solution.
That was a 22 total, right?
Right? You guys kind of with me on that? Oh, except I want to do plus 1, I think. They have you do, where's my z? X minus. Okay, cool. That's not what I want, though. What the hell? It's also true.
It'll work out if you, with the top y.
You're confident this will work?
If you factor out a -1, it'll look right up there. You'll be able to see.
I just really want z at 0 to be my initial condition.
Like the very top one, if you said 2e.
Oh, but I want, yeah, never mind. Forget it. Okay, so,
You want z of 1 to be y of 0, right? Or is it not that?
yeah.
Kind of.
No.
No?
Really, what I really want is I want to I want to get zeros in the exponent, right? So let me just try this thing and see. Okay, so what do you do?
So we're going to evaluate z at 1, right, still?
Yeah, I'm going to evaluate z at 1 still.
So that was the
That's
fun-
going to give, why the hell am I doing this?
So you're trying to get your initial
To get your
condition equal to
exponents
0?
out.
I think the thing.
I'm really just trying to get the exponents to be 0, right?
Could you
So
do
if I plug,
Z equals y of x plus 1.
oh, if I plug 1 in, I'll get 0 in the exponent. Yeah, sorry. Mark's right, I'm just being an idiot. Sorry, I just clouded my brain up. So I want 0 in the exponents, right? When I plug in the initial conditions. You guys do that? So the place I'm evaluating the initial conditions is at 1. I would really like that to be at 0. So I'm thinking, what do I have to do to 1 to get it to be at 0? Well, I need to subtract 1 from it to get it to be at 0. So I'm taking z is y of x minus 1, and so I just calculate that thing. I get z is some different c1, right? You guys with me that that's probably different? And then I should get e to the minus quantity of x minus 1.
Why would your C1 be different? I did it that method. I got the same thing you did the last time.
Oh, it's not necessarily true that it's different. I'm just worried that it might be.
Oh.
Right, I changed something. Like, it could be different. I don't know. I'm just hedging my bets. And then I got e to the minus 2 times x minus 1. Is with me on this? Okay, now what?
Take the derivative.
Plug in 1.
Yeah, so we should really do, okay, so if we plug in z as z of 1, right? We get c1 e to the 0 plus c2 e to the 0.
So C1 plus C2 is equal to
So that was one of the things that was weird to me, is like, is that still equal to -1? I just assumed it was and worked it out and it works, but
That's why I was worried about shifting.
well, y of 1 is
Because I know what y of 1 is, I don't know what y of 0 is.
It works out. You end up getting the same.
Yeah, but I don't know y of 0 is -1. You guys see that? Like, I know what y of 1 is. You see, algebraically,
I think the thing that's confusing is they use x and x.
oh, that the x's are this?
Well, like instead of doing like the change of variable.
Yeah.
it might just be easier to pick something like r is equal to x minus 1 and then go from there.
Okay, so if I said, oh, but then I'd know about z at 2.
Well, C is like only used to find your exponents, right? That's kind of like it's easier to guess a general equation if you make Z equal to that or that. I'm not quite sure how that plays into like anymore.
So basically my concern is that I've lost track of what I know about, right? You guys see that? So what I know about is I know that y of 1 is -1. And what I'm fundamentally evaluating here is z at 1, right? What is z of 1? Well, the best understanding that I have for z of 1 is that it's y at 0, which I don't know. What I do know is z at 2. You guys with that? But if I plug in 2 into the exponents, I don't get anything convenient.
It's the same thing.
You guys see this?
Well, it doesn't show that Z is equal to that. It shows that Y is equal to that in the example above. Z is just kind of used to kind of establish what your exponents are. Cause it's still, underneath that, when it's showing what you get by distributing it like that, it's still y is equal to all of that. Like that works out. When we did that, we didn't treat c's like they were any different. And it ends up being like -1 is equal to c1 plus c2. And then you could just treat c1 as something that relates to c2 and plug that into the other one.
We're missing the part of 22c about what the constants are. You guys see that? If you look at 22, it's not just that it's a fundamental solution, which is the part I did, right? I did A and B of 22. But I didn't actually do this part about confirming what the coefficients are. And these coefficients are different than the C1 and C2. Algebraically, the answer you get out of this will be the same as what you get the other way, right? But it's algebraically it's the same, not that the constants are the same. So when I did this, my constants had e's in them, right? When I do it this way, my constants won't have e's in them. You guys with me on that? And there's a formula in here for it, but
But the exponents will be different, not
yeah, my exponents will be different. Yeah. So frankly, I like my other method better than I like their method. I trust that their method will work, but my method seems like very clear what I'm doing. And on this, I got a little lost. So I'm going to say I got a little lost. Sorry.